So the study involves this categorization task. We have extensive training. The subjects can learn. It's not an easy task to classify the stimuli. We have two groups of participants, so this is like we're looking for the other race effect. I'm not sure whether you're familiar with this thing. There's I see some of the presentations today about the other race effect. There is a known effect that sometimes, we have a little bit of difficulties recognizing faces of other races. And the question is, why is it happening? So we wanted to, using the same stimuli, to explore using the MSPN framework. So two faces, two groups of participants. MSPN model can be split down and disassembled into smaller parts, and these are all special cases of the MSPN models: pure serial architecture, parallel independent architecture, parallel interactive. The interactive means the channels can communicate, can glue together. This is parallel independent. They can process in parallel, but they cannot be glued together, right? And there's a coactive architecture, which is extreme version of the parallel architecture, single point. And this is a full MSPN model. PAC scores are used to analyze models of complexity because they have different parameters. We see that MSPN is heavily parameterized because it has all these networks inside. That poses a little bit of a challenge, to the model selection. And we also use, for the yardstick, we use a saturated model. That model does not make many of the assumptions about the processing, and it uses a lot of parameters, but can capture the data the best. So if you see MSPN can actually do the same job, that would be actually a good thing. And then we can use BAC, to check, for the given the model complexity, does it make sense, to make these models such complicated? So one example, one subject here, we can see these stimulus configuration of the 16 to be classified faces, and these are response data from one of the subjects. We have individual subject analysis. As you can see here, these are the quantile bins for the one category and category B responses. And you can see that these four guys are here actually category B. And then the correct distribution of the quantiles should move toward the middle line here, which is this subject is doing really good. And then we can see that subject is kind of having a little bit of a problem around this kind of items here, because sometimes classifies A's or B's. But the most important thing is MSPN captures this almost beautifully. You can see the red dots are all over the right tops of this quantile bins. Quite a perfect fit for this subject. But what does it mean, right? The model fits. We have to analyze the parameters of the model that indicates all the properties that we discussed so far. When you look at the data, and then technically there's a lot of information here for different types of faces across two different groups of subjects. What we are looking for, I'll guide your attention to the MSPN model. MSPN model here, BAC scores is you like to have the lower the BAC score as possible. And actually when you compare to the saturated model, the yardstick model, is BAC score. In most cases, you can see the average values are the lowest across all different models. What this tells us, that this kind of theory of the complicated modularity seriality pays off, and even beats, the saturated model, and that means, although the model is complex, it's still good, reasonable approximation to the data given its complexity, so it can provide some probably good useful insights. All right, so MSPN model dominates across all of these cases, which is good, right? But what is the meaning? Now we can analyze the parameters, and bottom line is to analyze the serial and parallel properties first to see how many times that they showed up. So this would be the percent of cases of the trials that we assume the process in serial and parallel. And then we can see that across participants, 36% of times participants use a pure serial network to analyze faces. That is very holistic behavior. Very analytic behavior, feature analysis. Because serial network can reveal separate features. Now, the other 64% use the parallel model here. So the question is, how many of these are independent how many of these are kind of interactive. And then we found that out of 64, 79% are parallel independent. This is the parallelity is holistic property, but independence is analytic property. So it's like, between the holistic and analytic, So you see the faces floating around with some kind of a bits of combination, but not the entire face. But you can actually access the individual features here. Now, the pure coactive, which is the top form of the gluing binding together, it is 21% out of 64% of cases. So this is the bottom line, for how many, to what extent modularity and interactivity play a role, to form, holistic representation phases. So you can see that we can go, from analytic to holistic, and it happened across many trials, I think we have many sessions in the study. It makes sense, right? But it gives the idea that we can analytically really approach the problem. Eventually, we can start to build up, more holistic properties later. Some of this research you can find on the archives that we posted there, before it's the process. The paper is under review, and we hope we get it sometime soon. I think if we have time, there's another line of the research that I would like to share with you, which is how MSPN can be used as an exploratory tool, which means not necessarily making particular assumptions and sticking to them, but eventually using it to falsify certain theories. So, if you're in this area, then you probably recognize composite phase effect task, which is kind of famous in the holistic analysis. So here the task is to tell me whether the two upper parts are identical or not. What do you think? Are they identical or not? Who is? They're not identical. So some people are yes, some people no. It's not quite clear, right? This seems. What do you think? No? Yes? Yeah. I labeled them as the same, everything they're the same, right? No, how about not? It's much easier to see there in that one now, right? Now this is like misaligned phases effect. What happened here? How that we feel, now this is very robust effect. How is that we feel a little bit of uneasy saying that these are identical, right? What's going on here? There are several ways of interpretation, and it's actually one of the problems in the area. So some researchers, will have different explanations what is happening here. The main explanation is that this an ability to attend the upper part is because faces are holistic, right? The holistic processes here start to play a role that prevents us to look at the partial feature because they're aligned. The bottom part somehow takes over and try to bind the other features together, probably changing their configuration and properties, right? That's the idea. So it is one of the most robust effects that works really right now. Now, the correct thing is probably to say, and maybe to be a little bit of careful, is to say, I don't know, maybe it's not really holistic, maybe selective attention fails. So people agree that selective attention to this part fails. We cannot really focus on that part. But why did it happen, right? Well, again, it's because the holistic processes must be, right? You see, look, this is a qualitative explanation for the effect in the composite effect, and then the question is, are there any other interpretations? Right? So let's explore that with MSPN. Right? Let's see whether the MSPN should identify holistic properties in such a task. So the task looks like, the target phase has been presented with weighting something, the other phase is presenting it the same, whether the same or different. It's a pretty really simple task, but the design is pretty obnoxious. It's not easy to say, and there's a lot of debate about the task itself, its methods, so we're not going to go into details. The holistic effects have been demonstrated usually by this kind of effect in accuracy, right? You can see that these line faces are easier to compare top parts than the line faces. So this effect is kind of an effect, holistic perception. Okay, do not stop there. If you use, the so-called full, design, full complete design of these composite effects, and this is actually how many conditions we have. We have like 8 conditions. required unit test. There's a whole discussion about this thing. People are fighting back each other. What is it? Who are right? Who is not? But people like to see actually where did you go? Did you go with the holistic? Is it because you are here using these higher level representations, or in analytic, you are utilizing some lower level representations? So what are the cognitive perception mechanisms behind it? And then can we provide some converging arguments about what is really going on in this task? So I actually borrowed the data that already exists, found a way to extract this information. These are response time for the total of 4 conditions here for congruent, incongruent, aligned. I'm not going to go into details for these conditions here. Aligned means in these cases, misaligned faces here, aligned faces here. There are 4 types of trials, that makes 8 total conditions of response times and proportion correct. So let's see whether we can fit the data using MSPN. With a little bit of work, we will try to see whether we can have the hallmark of the holistic processing. So some people are really swear that this is it. This is the signature of the holistic processing, the composite task. So if we look at the D primes for the congruent versus incongruent faces, we should get this shape. At the moment, because we're a little bit running out of time, let's just memorize the form of this shape. So this is like an interaction that should be observed. If you observe interaction effect in these kind of 8 types of faces tasks that I show you in composite paradigm, then researchers will put their hands in fire and say, this is holistic stuff, right? This is the signature of the holistic. So the question whether this truly is. So when we analyze the MSPN, we only use 2 processes. We assume that analysis go for the upper and bottom part, and then these will be other parts of networks will not be engaged. And then we can have a stimulus configuration space in the same fashion as it is for the categorization task, in which the upper part that could be same or different, bottom part could be same or different. So all these faces, along with the aligned faces, you can think also be crammed here. Technically, for the make categorization, you have to put the rule. Remember, one of these rules that separate features. So this will be one stimulus feature dimension, the other stimulus feature dimension. This will be decision bound. So we have like a normal distribution associated with each of these representations here, same or different. So your task is actually classify this group from the left group. Yeah. But it seems like people are having difficulties with that thing. So we additionally assume that actually you are paying attention to the second dimension. The second dimension is the bottom part, right? That is as far as the holistic listing can go. Actually, you cannot ignore the second feature. It is there. So somehow, from time to time, eventually you are jumping in the perception space. And it looks something like this. So 2 decision bounds. We get 4 conditions here. You can think of misaligned faces having the same decision. So this is pretty much a structural configuration of the MSPN manipulation. Looks from another view. Here are the results. Okay, when I fit a model, the question is can the MSPN fit, so we can see aligned faces are here, misaligned faces here, aligned, misaligned faces here, and these are different types of models, right? So there's observed data here that is provided in the file, paper that I found, so these are correct, proportions correct, reaction times, proportions correct, reaction times, so it's a lot of data, really. It's getting very confusing. You have to be super careful, and I check several times, not making many mistakes here. And these are different models: serial, parallel dependent, parallel active, and the MSPN that kind of can combine all this. There's a single dimension here. That is, if you're using only a single dimension, you're paying attention only to the upper parts, but not at all having information about the bottom line here. That the winner, if you see in the line condition, what do we say about the line condition with the face parcel line? Is it more holistic or analytic? More holistic, right? So actually, a parallel interactive model that is parallel analyzed allows for channel communication that is doing both holistic property is doing a very good job. So this number, the smaller, the better. Serial model is not doing that good job, right? So parallel is doing a good job. MSPN is doing a better job because it can have a little more parameters, but we see that holistic, has been identified here. That works so far good. These guys may be right? Aligned faces, holistic properties, both are aligned, figure out there. Now, misaligned faces, what do we say? The misaligned analytic stuff, right? So these guys here, Well, probably can analyze them. We don't have to glue them together. We can use feature by feature. And as a matter of fact, here it is. Serial is the best model, and then combination of serial parallel without channel communication, without binding, also works together. So analytic property, both. So it makes sense, right? So you see like a MSPN as a model of verification can be used to falsify certain ideas. We provided congruent validity. We provide evidence that supports the findings of the researchers who just plainly claim, it must be holistic in the aligned phases and it must be analytic in the misaligned phases. But it's not simple. It's not that simple. So here's another look. Here's another here. MSPN fits, the hallmark of the holistic signature very well. So MSPN axis or the model fits when you put it together. And there's data already published. I mean, not mine, but the data, the black lines, are the published data of the verified paper in here. So MSPN can print this information, right? Now, possible issues here. And here's the argument actually why we cannot accept that argument that was claimed before, that particularly this interaction between congruency and alignment should be seen as a hallmark of holistic processes. So this is the explanation why it is not that simple. So first we look, switching between serial and parallel models across trials. When you dig a little bit deeper in the analysis of the behavior of the model, we can also predict the signature of the holistic process. So if you start to play how many of these processes are serial, how many of them are parallel, with everything else being very analytic, you can get a signature. So technically we turn off these kind of communications and allow only the modulation here between items. So they could sometimes go serial and parallel. The model actually did a pretty good job, but most of the processes were processing and analyzing parallel, not interactive, and with a little bit of a dash of the serial processes. You can get the same signature. So just play a combination of serial and parallel from trial to trial with more parallel processes in the band and a little bit of a dash of serial processes, can create the signature. So that was one thing. And you can see how that fits. It is actually of the serial parallel model without interaction is pretty good. Yeah, it fits, it doesn't really fit, data here well, maybe here, but it captures exactly, the pattern very well. So first thing, right? Pure serial model that is very analytic model can show a weak holistic signature data finding when the data has been fitted, when the model has been fitted to the data. Remember that serial model itself actually shows a little bit of interaction. If this is zero, there's no interaction. There's a serial model picked, pure serial model, pure analytic model picked up some of this interaction, this hallmark. It's not strong. That's, you cannot really quantitatively match it, but it's there. And if you push a little bit further, combination of serial parallel system with a little bit of moving the decision bounds on the feature analysis actually can create sizable effects. So what did we change here? Well, we didn't allow for channels to communicate, so no binding. We allowed only for serial parallel changes. And then we also allowed that play a little bit with position of that bound, right? Move it left to the right, across conditions, across aligned versus misaligned conditions. So small move of the bound that is associated with aligned and misaligned condition, but everything else stays the same, can create huge, this effect. The serial system itself, if a little bit, proper finding, proper parameterization, can create huge interaction between aligned and misaligned congruency hallmark effect. It cannot really fit the data, but can qualitatively get this kind of a result, which kind of poses concern about the conclusions of the group favoring this type of approach. All right. Okay, science. So overall, what we can see is this MSPN network can account for the both response times accuracy data in a composite phase paradigm and also categorization. In the composite phase task, we've failed to find if and only if argument that holistic signature of the interaction between the major variables and the hallmark of the holistic processing could be used as evidence for holistic processing. It cannot be used because maybe it is necessary, but it's not sufficient argument because similar process can also create, such a signature itself. So that poses a problem, for this kind of approach. There's another limitations that is imposed here by doing this interaction analysis, so which I just partially described. Further research is needed, really need probably more data, that we can submit, this analysis. This is just one data set. And if you Google, composite phase task, you probably find like 10,000 hits on the research publication. So this is, there's a big lowered transparency about how data is presented in such a tasks, which makes a problem, for finding and testing this validity of these approaches. MSPN as an exploratory tool, can help us identify some of the properties here, right? So this is kind of can raise a question whether some of these ideas are really correct, even without assuming that these are actually what is going on here. And the final conclusions is about the hierarchical representation of the facial stimuli. Maybe you can also extend this to the object perception. MSPN could be used as a theoretical and experimental tool. We see that hierarchical properties are linking these properties to the processing order, stopping rule, and process dependency. The idea that is being really perpetuated and created by Professor Townsend and Michael Wenger for a certain period of time that we try to exploit in our analysis. And we can see that validation can go across different types of paradigms. So I just show you a categorization task, show you the composite phase task. I also have a data for one known like a part2 paradigm, which is another facial paradigm used in a similar domain. And kind of MSPN somehow was able to accommodate, to use this data in analysis for the exploratory purposes. More of that in mathematical psychology meeting, in the Netherlands, and if you're going this year, maybe to share more information. But that's all. Thank you guys, for the.
Thank you, Larry, for the wonderful talk. I think we have time for a question from the audience. Comment? Go ahead. Yeah. Use your microphone.
Thank you for your presentation, and I'm very fascinated about the MSPN model, and because I'm a very novice in this field, and I know there's also a mixed serial error model in Daniel's and you propose logical rule model. So
yes.
I wonder what's the difference between MSPN and mixed serial error model in logical rule model.
Actually, I paid how well to ask me this question. So previously we published a paper in Psych Review with the collaborators of Masovsky and Little, and it was a logical rule model that employed different types of architectures here in parallel. The difference is this is extension of that approach. So it uses some ideas that are regarding the using the logical rules, decision bounds, to split up the decision space into response regions, and also uses different architectures. But unlike that approach, all these architectures are now combined into one framework. So they are just one system that operates across these all architectures. And also, although we had tasks for the co-activation at the time, this model allows for gradual changes of interaction levels that has a co-activation as a special case. So that means it can change from process independent 0, and then if channels open, we can have moderate facilitation or inhibition that is happening, to completely open, they can create coactive models. So it can explore or more variability. So this is logical, well, this is kind of an extension, direct extension of that model within one framework.
Thank you.
James?
This strikes me as quite powerful work from Mario. I would like, if you have any slides, perhaps you don't, for this presentation, but what forms of mathematics show up in these various models? So, for example, are your parallel interacting models like the ones that Michael and I have used where there are linear systems, but then just look at properties and they can interact, and also for your MSPN model, what kind of mathematics is that?
So no, with the NASA, NASA built, the rocket into the moon, you buy, not the most expensive parts, you buy the most affordable parts. And MSPN has the simple parts built in. They are not expensive. So Jim's question is, what's been built, into the model? Are the most expensive stuff more complicated? But to avoid some of these issues of overcomplication of the model, I just use simple parts. So for example, we use a random walk instead of like grid diffusion. But we know that random walk, which is kind of evidence accumulation of certain steps, it's asymptotically similar to the grid diffusion with a sufficient number of steps. So but it's simpler, right? So simple component, engine will not probably fail. We also, interaction is across channels, So that means, one channel opens the connection with the other channel, and there's a certain probability with which, the evidence accumulated at that step of time in the random walk carried over to the second channel and vice versa, or not. If that doesn't happen, there's no communication. So there's a probability parameter regulated in the size of the connection. So it is not like there's all different ways of creating the correlated channels, and I use this the most, to me, logical one. When you say, for example, you have correlated noise in the inputs, I don't know, I don't have any assumptions in what noise could be correlated, but I have, good assumptions how the accumulators can exchange information between themselves. Intervening, some neurons that can, be sensible or can modulate their communication between the other neurons and accumulating the evidence into them. So it was relatively simplified. I can go into more complicated way, but it's going to be too complicated then. One of the reviewers also asked a question, do you have collapsing boundaries of, some kind of a top recent research about random walk, no, this is the simplest possible evidence accumulation. I don't want to go there at that level. And as a matter of fact, data fits perfectly for the participants in this task, but we also have data that's been fitting in other paradigms, such as a decision-making paradigm. So I don't see throwing on more complexities here would not benefit the analysis much. So simple possible, reasonable assumptions about the communication between channels. Yes. Anybody else? Yeah.
As you mentioned that,
Want to use your mic?
as you mentioned that there are some certain trials, proportion trials, they use pair processing, and the other proportion trials they use serial processing.
Yes.
Is the serial and pair processing stimulus dependent, which means for the end conjunction stimulus, they
Yes.
use more parallel versus the conflict
So-
categories.
So as I understand your question, Professor Young's question, it is how the modularity has been determined. How do we know whether it's time to go to serial, how it is time to switch to parallel processing? And I treated this, so this is this kind of a behavior, right? When it comes, the evidence comes from the memory, and it's been read out, and then each step, it brings in a little bit of a piece of information. How do we know whether we should go to this module or that module? And I say, I don't know. I treated this as a parameter. Parameter can switch probabilistically this one from serial to parallel. It is up to you guys, or maybe some of my collaborators, to determine what determines switching probability to be more serial, to be more parallel. It probably can be connected to feedback, some kind of a feedback reward system that can modulate the value of this gate selector, maybe through some learning, so you can find some kind of ratio, but I don't have that kind of laid out in the details, why we would be switching it for one. I can assume maybe we just start very serial, and then when we are getting better and better in the memory retrieval, setting up all these boundaries, to separate the spaces, maybe turning more and more probabilistic